Assalamu alaikum and hello everyone. Hope everyone can hear me well. So now let's get started with the review class of S1 Paper 5, the last minute review class for the year 2025. Today is 13th May 2025 and tomorrow is your S1 paper. Now, yesterday, I took a class which was online, but then I uploaded it on YouTube. In that class, I focused on few things. Let me get the things started from there. So, day one, that was yesterday, that was an online class. And I focused on May, June 2023, all three variants, that is 51, 52, and 53. All variants are good. All variants are perfectly fine. And the questions that I focused on were mainly on normal distribution, permutation combination, a representation of data. I focused some with mean and standard deviation and some with diagrams. There might be one or two questions that were left out. For example, a question related with histogram or cumulative frequency that we will see today. And the analysis was over here, that these were the questions that we focused on. So now, once this session is over, those of you who did not attend the last class, just check out the channel and look at this thing that is the S1 topical review. I think that is the name. It was uploaded yesterday, so you have no problem finding it. And in that, I discussed about normal and perms and comps and representation of data, descriptive statistics or representation of data. The chapter goes by this name. And these were the questions that were solved over there. So these 4 questions over there, these 3 questions from this variant, and these 4 questions from this variant. So basically, I divided the syllabus into 2 parts. One part was for day 1, that is normal, permutation, combination, and representation of data. And today, I'll focus on probability, the basic probability, sample space, tree diagram, conceptual, mutually exclusive, independent, conditional, probability distribution, which is known as DRV, discrete random variable, binomial, which is part and parcel of DRV, geometric, that is also part of DRV. So now let's get started. And over here, I'll be doing the analysis of those questions. What each question, was there anything special about it? So I'll be focusing on that thing. So now over here, let me open up the PDF for 2023. And let me go to the first thing, that is May, June 2023, variant 51. So my focus is on May, June 2023, variant 51. And question number 1 was discussed yesterday. Question number 2, 3, and 4. The first 4 questions were discussed yesterday. Now let's focus on question number 5. That is about histogram. So now over here, it says the population of 150 villages in the UK to the nearest 100 are summarized in the table. This is population. This is class interval. Now, a lot of people, they ask this question, how do we know? Is it a class interval or a class boundary? Very simple. Boundary, that means there should be something common. But over here, it's not common. It's ending at 800. It's starting at 900. It's ending at 1200, starting at 1300. So there is a gap of 100 units. So whatever the gap amount is, divide by 2 and add and subtract. To the lower class interval, from the lower class interval, we would subtract. To the upper class interval, we would add. So that is the first thing that I'm focusing on. 100 becomes 50. 800 becomes 850. 900 becomes 850. 1200 becomes 1250. 2000 becomes 2050. 3200 becomes 3250, and so on. Now, We have the class boundaries. Why do we need the class boundary? I should have studied further that it is about histogram. It is about something to do with the class interval, something with the greatest possible value. So again, there are some questions which I will mark as favorite. Make sure that you remember these questions because there is a reason why I'm marking these as favorites. So it's just my gut feeling. I have a feeling that these questions should be there in tomorrow's paper. So these are my gut feeling questions. I can say that as an educated guess. So what I think are the nice questions over here. So consider this as a very nice question. This is about frequency density. This is about histogram. And this is about greatest least value based upon something that will be coming up on the next page. So now over here, what do we have over here? That is class boundaries. We need that. Number of villages, that is the frequency. Now, when the class widths are unequal, so the difference is 800, the difference is 400, and so on. When the class widths are unequal, we work with frequency density. What is the definition of frequency density? That is class frequency over class width. So frequency over class width, that is 0.010. Similarly, 12 over 400, similarly, 50 over 800, similarly, 48 over 1200 and 32 over 1600, you get this thing. Now, the very first thing is that, of course, you won't be plotting this as it is. There is something called scaling that you have done in O-level math. So apply that knowledge. So the smallest value is, consider this as 10, consider this as 30, consider this as 62.5, this is 40, this is 20. So the smallest one is 10. Vertical axis can never be compressed. Remember that. So now over here, I'm starting from 0, 10, 20, 30, 40, 50, 60, 70. I'm going all the way up till here. And this is basically whatever this value is, 0.010. Isn't this thing as 10 divided by 1000? Yes, it is 10 over 1000. So frequency density is 1 over 1000. So that is the thing that we are using, or just let me add some zeros. So this is 0.07, 0.06, 0.05, 0.04, 0.03, 0.02, 0.01, and that is how we are getting these values. So now frequency density, it goes on the vertical axis. So frequency density is on the vertical axis and class boundaries are on the horizontal axis. And that is how the plotting is done. So that is basic stuff. Next thing, histogram is drawn. That is for 4 mark. Write down the class interval which contains the median. So now what is the median? Median is the value that occurs in the middle. The frequency, the sum of frequency is 150. 150 divided by 2 is 75. Therefore, there is no middle value. So therefore, pick the 75th value, the 76th value. And what do we do? 75th and 76th, take the average. So now look over here. Where do you find the 75th value? 8 plus 12, that is 20. 20 plus 50, that is 70. That means 71st, 72nd, 73rd, 74th, 75th, 76th, all values are lying in this interval. That's it. So therefore, the interval is this much. Now it's asking, find the greatest possible value of the interquartile range for the populations of the 150 villages. Now we have to find class intervals. Just the same way as we did for median, we found the class interval for median. We need to find the class interval for lower quartile, class interval for upper quartile. Now that is the strategy. So that is why this finding the greatest possible value of interquartile range. So let me write over here. So this is greatest possible value of interquartile range. That is what we are working on. And remember, this is May, June 2023 variant. May, June 2023, variant 51, question number 5. So that is one of my favorite questions. So that is question number 5. So now over here, find the greatest possible value. Now, first of all, lower quartile, that is 25% of 150. So that is the 38, 37.5, round it up, that is the 38th value. Similarly, upper quartile is 75% of 150, 112.5, that is the 113th value. So now the 38th value lies in this interval, the 113th value lies in this interval. Now think about the upper class boundary. 1300 becomes 1250, 2000 becomes 2049 at 1 unit lesser. It is actually 2050, but for this calculation, we take it to be 2049. 2100, that's 2050, 3200 is 3250, take 1 unit lesser. So now upper class boundary, UB, that is actually UCB, upper class boundary, it's not inclusive. That is why we are writing it this way. And the difference between this highest value and this lowest value, that is 1999, that is the greatest value of the interquartile range. And let's say if they would have asked for the lowest value of the interquartile range, what would it be? It would be 1250, it would be 2050. The difference between the two, we just subtract. So that was a very, very nice question that we saw in this particular thing. Now, question number 6. This is about, I think, DRV and probability and things like that. Let's see what is exactly it is. Now it says LE has four-sided die. So there is 4, there is fair, there is 4 again. So 4, fair, 4. Wow. It has sides with sides labeled 1, 2, 3, 4. All the probabilities are equal. That is what the word fair means. He throws all 4 dice at the same time. The random variable X denotes the number of 2s obtained. First thing, show that probability X is equals to 3 is 3 over 64. That means how many 3s are you obtaining? That is 3. So probability of getting a 2 is 1/4, not getting a 2 is 3/4. So 2, 2, 2, and not a 2. That is 1/4, 1/4, 1/4 into 3/4. In how many ways can you arrange it? 4 factorial. Because this is like A, B, that is 4 factorial divided by 3 factorial, which is 4. So this is a concept of 2 things. That is, this is about probability. This is also about basic NPR that is used to calculate probability. So that is the concept right over here. That comes out to be 3 over 64. Alternatively, I can consider it to be a binomial. Why? Because I am throwing 4 dice and the probabilities are fixed. So why am I considering it binomial? Let me write it over here. So this is binomial because there is a fixed number of trials. And the second thing is that the probabilities are constant. So over here, success is getting a 2, which is 1/4, failure is 3/4, number of trial is 4. So that is what is happening over here. Probability X is equals to 3, you can find it. So I think once you have realized that this is binomial, then working with binomial becomes very, very easy. So now it says complete the following probability distribution table. So 1 is filled up, 1 is empty, 2 is empty, 3, 4, and 0 are filled up. 3 was evaluated earlier on. So now probability X is equals to 1, 4C1, success raised to power of 1, failure raised to power of 3. Probability X is equals to 2, 4C2, success raised to power of 2, failure raised to power of 2. And that's how this is obtained. Now, again, one bone of contention that a lot of people ask this particular question, that is about fractions versus decimals. Fractions are supreme. Fractions are exact. So remember this thing, fractions are very useful. They are supreme in the sense that they are exact. So if the question is about fraction, this is examiner's favorite. Examiner will always be more than happy that you are working in fractions. And if you intend to work in decimals, which is also part of life, which has its own significance, then take care of accuracy. No compromise on that. Work in 4SF, therefore, final answer in 3SF. And also, unless otherwise stated, maybe in a particular question, if they're asking to give the answer in something decimal places, so you work it like that. Then it says find expectation of X. So what I have done is that I have just copied that thing over here. One other thing that I want to emphasize, which not everyone emphasizes, that is work in exact fractions. Now over here, fractions are very, very necessary. First thing is that I can simply add the numerators. And if it all equals to the denominator, that means I have taken care of everything. Secondly, when you are working for expectation of X or expectation of X squared, what we do is that we simply multiply this with the numerator, this with the numerator, and so on. Just look at my working. And then since it's unreduced, unsimplified, therefore you can divide once by 256. And it's a beautiful number 1. Now, it says Ellie throws the 4 dice at the same time on 96 occasions. So now the question started with what? It started with the first 2 parts as DRV. The third part is also DRV, but the fourth part, that's an approximation. So let me write one other thing over here. That is expect the unexpected. Expect the unexpected. They can make a lot of different questions. So now this is like a combination of DRV and normal approximation to binomial. So now, because it was binomial, and then you do the approximation, that is the only approximation that we work in. That is the only suitable approximation that we work in S1. In S2, yes, you work with more approximation. So now it says Ellie throws the 4 dice at the same time on 96 occasions. That 96 is the number of trials. Use a suitable approximation. Find the probability he obtains at least 2 2s on fewer than 20 of these occasions. So at least 2 2s. Now, how do we get at least 2 2s? Now we need this table. So it's not just 2, it's at least 2 2. So this whole block is what we need. So it could be 2 2s, it could be 3 2s, it could be 4 2s. So therefore, at least 2 2s, 54, 12, 1 over 256, this is the probability of success. Probability of failure, 1 minus probability of success, number of trial is 96. So now you can add one more step over here. That is X follows a binomial distribution. That is 96,67 over 256. A very, very strange question. That means the probability of success was taken out of the DRV. So now expectation of X is NP, variance of X is NPQ. There is also NQ over here. Always make a habit of doing the justification. Since NP is greater than 5, there is NP. And NQ is greater than 5 and NQ is greater than 5. Therefore, X follows, let me just remove this. Therefore, X follows a normal distribution. This is NP, this is NPQ. Got the idea? Now, once this is done, this must be worth at least 4 marks. This is 5. That's good. Fewer than 20. So probability X less than 20, probability X lesser than 19.5, continuity correction using a number line. I believe in working. I believe in showing every stuff. And I'll just read the examiner report also. So probability Z is lesser than 19.5 minus the mean, divide by square root of variance. We get this value. Apply symmetry. Z lesser than a negative is the same thing as probability Z greater than positive. So this is greater and positive on that side. So this is Z greater than positive. 1 minus 5 of this value. Write this thing from the table, subtract, and then final answer correct to 3 significant figures. So that is how this particular question is done and dusted. So let me write over here. So this thing was a histogram and there was this greatest value of IQR that was asked. There was the class interval in which the median lies, that is was asked over here. This is binomial and expectation. This is also basic probability and permutation. You can also consider it this way, and normal approximation based upon DRV. So that was kind of new. And now let's look at question number 7. So now question number 7, first read the question. The question says a children wildlife magazine is published every Monday. For the next 12 weeks, it will include a model animal as a free gift. There are 5 different models: tiger, leopard, rhino, elephant, and buffalo, each with the same probability of being included in the magazine. Now, when you read the first paragraph, it seems like a binomial to me, but let's study further. Sahim buys 1 copy of the magazine every Monday. Find the probability the first time that the free gift is an elephant before the 6th Monday. Now, when we read this statement, that is before something, so that means this is about this is about geometric probability distribution. Because the key word over here is what? The key word over here is until. Until and unless you achieve success, you won't stop. That is the trademark of binomial probability distribution. So now today I made some reels, and that is on Instagram as well as the YouTube shorts. And the reels focused on few things. Let me just focus on that so that you can also have a good look at that. Basically, I focused on 4 things. The first thing was that the 3 tips on getting an A grade in S1 or any other subject. So that is about reading, that is about concept, that is about working, and I'll prove this thing from the examiner's perspective. Read in order to understand. That is basic common sense. In order to understand. You can also call it analysis. So therefore, there is this one thing, reading, then the concept, then the working. These are the 3 things that I focused on. And similarly, it was about time management, frequently asked question. So there were some FAQs that people asked. The first one was about time management. The second one was about this, what do we do on the last day? And the third thing, how much working is enough for examiner? Is the working given in the mark scheme, is it enough? Definitely not. So these were the 3 things that I focused on. So focused on this thing, focused on this thing, and focused on this thing. So I'll be talking about these things also over here. So don't worry about that. You can watch the reel a little bit later. So now coming back to this particular question over here. So now it says X follows the geometric distribution 0.2. How do we get 0.2? We have T, L, R, E, and B. So each one has a probability that is equal. So it's 1 out of 5 for each. So it's 1/5. So probability of success is 1/5. Probability of failure is 0.8. Now it is geometric. Then probability X lesser than 6. It says before the 6th Monday. So they are doing it for every week. The number of trial is not used because it's before the 6th thing. So a similar question was there, I think, in today's paper. Do check that out. That is February, March 2025, variant 52. There is only one variant. There was something like this also. Even though 12 is mentioned, it's of no use to us. That is not the number of trial because it's before the 6th Monday. So probability X less than 6, probability X lesser than or equal to 5, 1 minus Q raised to power of 5, 1 minus probability of failure raised to power of 5. Again, 2 things are very, very important. Let me write it down. Probability X is lesser than or equal to N. Probability X is lesser than or equal to N. That is 1 minus Q raised to power of N. This is at most n. Remember this thing, at most n. And similarly, if I write probability x is greater than n, that is q raised to power of n, this is greater than n. Of course, both these things, the shortcuts, they are valid for x follows a geometric distribution with the probability of success p. Now, the next part, it says find the probability that Sahim will get more than 2 leopards in the 12 magazines. Now it's talking about 12. Now it's talking about number of trials. So therefore, this is binomial. So x follows a binomial 0.2, probability more than 2. X is greater than 2, which is too much to calculate. Therefore, 0 and 1 is left. Calculate the probability for 0, calculate the probability for 1. So 0 and 1 and 2, let me just write it correctly. I think I missed out a thing. This is probability x is lesser than or equal to 2. So that is 0, 1, and 2. So this is 0, this is 1, this is 2. And make a habit, I wrote a little bit prematurely the answer. You should write it like this: 1 minus the first answer, the second answer, the third answer, work in at least 4 significant figures, and then the final answer is 3SF. So you should be having something numbers over here that is corresponding to this one, and then some numbers over here that is corresponding to this one, and then some numbers over here that is corresponding over here. Got the idea? So you should write this down. And then there is a different kind of a part, and sometimes these difficult parts come. So remember the rule, expect the unexpected. And also take care of this thing, the way in which you are doing the working. So I think in one of the papers, I think it was October, November 2024, variant 53, I focused on a lot on the working part. Check that video out also. So of course, there is so much information. There is so much content related to S1. It cannot ever be covered in one single session. So this session, the live session, that is for your emotional support. There are some other stuff that is there which you should refer to, because your exam is in the afternoon. So yes, you have the time, at least 2-3 hours. You can apply again and then get refreshed. So find the probability after 5 weeks. Sahim is exactly one of each animal. So now after 5 weeks, it's just about 5 weeks. So maybe first week, maybe, for example, the person is getting the tiger, the leopard, the rhino, the elephant, the buffalo. That is once every week, and 5 factorial. Because it's not necessary that the tiger comes in the first week. It could be first, second, third, fourth, fifth. The order could change. In how many ways the order could change? 5 factorial. And again, fractions are supreme. Otherwise, you can leave the answer in the decimals also. So now this was May, June 2023, variant 51. Let me go to the examiner report. And over here, let me just do some analysis of this thing. So now when I focus on this examiner report, I will just focus on the key messages. And let me get my highlighter ready for this thing. That's over here. So now over here, it says candidates need to be aware that workings and explanations are required to support the answer. So this is common sense thing. You need to give the working, you need to give the explanation where necessary in order to support the answer. It is especially important to include what all the required steps when the proof of a given result is called for example, including the mathematical operations. So show that, find the probability x is equals to 3. So you have to show everything. Good solutions. What is the definition of a good solution? Good solutions were characterized by clear communication, particularly when combining different results or scenarios. So that is how good solutions are obtained. Where a diagram is required, it should be clear, accurate, and appropriate labeled. Just right now, some time ago, Someone asked this question that should we draw the diagrams in pencil? The answer is absolutely yes. When we are talking about diagrams of any sort, histogram, cumulative frequency, box plot, stem plot, bar chart, pie chart, they don't ask that much basic, but even if they do, so this should be drawn in pencil. Now, someone just asked me a question about please do some arrangement questions. That arrangement questions that is in the video that is done yesterday. So the thing was divided into two parts. The arrangement questions are there in that. Yes, one question from many years before, I'll focus on that one, but the majority is there. Now, let me read further. It further says candidates should only state non-exact answers correct to 3 significant figures. That means if the answer is exact, it's not an issue of what you call accuracy. So now it says exact answer should be stated exactly. No wonder they are called the exact answers. I mean, that's kind of a lame mathematical joke. That exact answers should be stated exactly. To justify a final answer correct to 3 SF, working values correct to at least 4 SF should be used in this calculation. Throughout, there is no requirement for fractions to be converted to decimals. What does this statement mean? That means the examiner is more than happy to receive answer in fractions because fractions are exact. So the examiner is more than happy with that. So if the original question is in fraction, why would you torture the examiner with all the significant figures? Just work in exact form. Got the idea? Now let me read further over here. It says most candidates use the response space effectively. A lot of people ask this question. Where there is more than one attempt at a question, very important, where there is more than one attempt at a question, candidates should ensure that they clearly identify which one they intend to present for marking. And this thing, that means if this is the page, let me just give you a demonstration over here. Let's say, no, that's not a page, something like this. Now, this is a page, and you are working over here. And hold for a second. So you worked over here. And then you worked over here also. And one of them is correct. So if the top one is not correct, just say, please omit. That is what I used to do when I used to work as a student, not work, I mean study as a student. So now the correct thing is this one. That also brings me to one other idea. Some people, they are a bit underconfident. I make pray for you that you become very, very confident, but sometimes they write in pencil and then they overwrite in pen. So now they are doing like this. So this is something that is very repugnant for the examiner. So the examiner won't like it. The examiner simply says that scanning will be an issue. So if scanning is an issue, then the issue is if the examiner cannot get it scanned properly, then the marks will not be given. Now, someone is asking this question. Now, people are joining in between, and then they ask all this question. So that kind of makes me a little bit distracted. First of all, I'm discussing this thing, and you should watch the video once the session is over. What exactly are we talking about? Currently, I'm discussing the mark scheme for this particular paper, the examiner report. This is June 2023, variant 1. So let me just switch off my phone because I don't want to get distracted. I just want to focus on the way that I'm teaching. Those people who are joining in late, too bad. I mean, you can always watch the recording later. Nothing to worry. It will be there on YouTube. So now let me move to the next paper. That is May-June 2023, variant 52. And over here, May-June 2023, variant 52, there were three questions that is related to this, and someone who have just joined it, maybe a lot of people. So this is what we did yesterday. This is yesterday, and this on this side, what we are doing today. So yesterday, we talked about the coding question, permutation, combination, normal, expected value, stem plot, box plot, normal, permutation, combination, normal, stem plot, reasonings, normal, permutation, combination. So this is what we talked about yesterday. My focus is on May, June 2023. Right now, the same paper, but this time I focused on histogram, I focused on binomial and something, geometric, binomial, a mixed question like this. This thing is done. Now I'm focusing on this thing, on this paper now. So now let's focus on these three questions. So let's get started. So now the first question, I think that is pretty basic. Just have a good look. So now the first question is about this thing. It says the random variable x takes the value such and such. It is given that probability x is equals to x is k bracket x square minus 1, where k is a constant. I think this is one of the easiest. This is like follow the instruction. Just plug in the three values of x. You find the probability in terms of k because there is no other value. Therefore, all the probabilities should add up to 1. That is the meaning of the name, discrete random variable. So D for discrete and R for random and V for variable. So when we use this thing, discrete random variable, what it means is that we are using integer values for x. Yes, there is an exception, and that is money. The second thing is that random, the sum of probabilities should equal to 1 because we have taken care of everything. And last but not the least, whatever that variable x is, that is a variable. It's not a constant, it will change. For example, it could be number of heads scored, such and such, things like that. So now it says, draw up the probability distribution table. In order to draw the table, you first have to work it out. So this is k. Let me just write it over here. That is k, and this is 2 square minus 1. This also is 3k, 3k, 8k. They all add up. So first of all, I have written in terms of k. That is 3k. Hold for a second. So that is 3k over here. That is 3k. That is 8k. DRV, sum of probability is 1. K comes out to be 1 over 14. So maybe I made a mistake initially. I wrote 1 over 4. So always check your working. K is 1 over 14. Therefore, 3k is 3 over 14. 3k is 3 over 14. 8k is 8 over 14. Again, do not reduce the fraction. So that is like written in bold letters from my side. Do not reduce fractions. Why? Because fractions are beautiful. Fractions are supreme. Fractions are exact. So now over here, find expectation and variance. That is basic stuff. That is, you know how to do the evaluation. And some people, what they do is that they first calculate expectation. They write expectation variance of x. They do this calculation over here in one single line. Again, a word of caution. Work in small bite-size steps. Show all your working. What are you saving the paper for? Don't be so eco-friendly so that your grade is disturbed. Work in small bite-sized steps. The paper is already printed. You have all the spaces available. Just think very wisely. Think clearly. Write down the steps. Jot down the working. Jot down the info. And then work it out thoroughly. That's all you have to do. When you are doing some conjugacy, some miserness, and you want to write everything in one step, that will cause a problem. So expectation of x separately, expectation of x squared separately, then variance of x. So now work in fractions, leave the answer as it is. So simple. This question was a tough question. Tough in the sense that you have to be very vigilant. So now, what is my definition of tough? So a tough question is, there are so many different scenarios, so many things to look out for. And what do I mean by this? Let's have a look. Now, first of all, read the question. I would like you to read the question. Now, I'll read it for you. It says a sports event is taking place for 4 days, beginning on Sunday. So the first day of the sports event is Sunday. The probability that it will rain on Sunday is 0.4. So first thing first, that is, it will rain on Sunday. R for rain, D for dry. I have given the key over here. R for rain, D for dry. Let me fill this up again. And then you can look at the working downstairs. First of all, if I want to write, therefore, Sunday, there are two options. There is rain, there is dry. Rain is 0.4, naturally dry is 0.6. Now, what else does it say? Let me do the underlining now. Now it says the probability it will rain on Sunday is this much. On any subsequent day, the probability it will rain is 0.7. So if it rained on the previous day, so therefore, let me write over here. If it was rainy, then a rain again is 0.7. Just focus on this. And naturally, dry will be 0.3, but just focus on the rainy thing. And if it's a dry day, so, and 0.2 if it did not rain on the previous day. And dry, so let me just go back. And if it's a dry day, the probability 0.2 is rain is 0.7. So dry and then rainy, that is 0.2. First, double check my working. On any subsequent day, the probability it will rain is 0.7 if it rained on the previous day, and 0.2. So this is again about rain. 0.2 is again about rain. So rainy, rain is 0.7. Dry, rain is 0.2. Got the idea? And naturally, there is this thing missing over here. That is dry is 0.3, dry is 0.8. Just ignore that for right now. Now it says, find the probability it does not rain on any of the 4 days of the week. So that's just for 1 mark to get you started. It started with Sunday. Dry is 0.6. After dry, the probability that it is dry is 0.8. This is rainy. So dry is 0.8, and then again 0.8, and then 0.8. So after dry is 0.8, and then dry 0.8 and 0.8. That is the first thing. I wrote each one of them as 6 over 10, 8 over 10, 8 over 10, 8 over 10, 1, 2, 3, 4 zeros, 10,000 in the denominator, and I multiplied the numerator, and then I wrote it like this. That's one thing. Find the probability the first day on which it rains during the event is Tuesday. So it's just talking about 3 days. So Sunday is dry. Monday has to be dry. Tuesday has to be rainy. So Sunday is dry. That is 0.6. After dry, there is another dry. That is 0.8. After dry, rainy. That is 0.2. So after dry, rain is 0.2. And let me write in green color over here. Dry is 0.8. And at the top, after rainy, rain is this thing. Dry is 0.3. So we are working with these 6 probabilities. That is what I meant by this. It's a tough question because many things to look for. Things over here, in this case, is the probability. So there is 1, there is 2, there is 3, there is 4, there is 5, there is 6. There are 6 different probabilities that we have to take care of. The working is not difficult. It's the vigilance. It's the alertness that is difficult. How many marks? 2 marks. Fair enough. The next one. Find the probability. Now it's for 3 marks. Find the probability it rains on exactly one of the 4 days of the event. Now, when you go to the next page, make sure that you have the information right in front of you. You don't have to flip the pages all the time. Or if the paper is open up like this and it's on the side and you're working over here, that is perfect. But it's even better. I mean, I would not compromise on this. Believe me, I mean, I would be very, very comfortable writing things down like this. So that is the Sunday thing. That is the rainy thing. That is this thing. Now, first of all, I have written it like this. Sunday, Monday, Tuesday, Wednesday. Sunday is rainy. Then Monday is rainy. Then Tuesday is rainy. Then Wednesday is rainy. So I'm working in a logical manner. So logic, I mean something very, very necessary, logical manner. So that is the logical presentation, I should say. So logical presentation is very, very necessary. Now, let me just focus on Sunday first. First of all, rainy, that is 0.4, and then dry, 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 that is 0.6, 0.6, 0.6. Very simple. Let me focus on Monday. After rainy, it's dry. After rainy, it's dry. So this is 0.3. And after dry Sunday, it's rainy. After dry Sunday, it's rainy. That is 0.2. After dry, Monday is dry, that is 0.8. After dry, Monday is dry, that is 0.8. After dry, Monday is dry, that is 0.8. And just let me focus. I mean, that is all the thing that you need to take care of. After dry, there is dry. So after Monday dry, there is dry. So this dry is dry, dry, that is 0.8 and then 0.8. After rainy, it's dry. After rainy, it's dry. That is 0.3. So just, it's very, very obvious. That's how you work it out. You can leave the answer in fractions. You can leave the answer in decimals. This was exact. So I left the answer as an exact decimal. Got it? Now, question 3, that was done yesterday. Question 4. Yes, question 4, we have to do it. Now, again, for those people who have joined in just now, let me give you the reminder that this thing, now someone asked this question, what if you erase the pencil outline? Well, you can erase the pencil outline, but I think I would prefer start working with the pen from the beginning. What if you run out of time and they won't grade the thing in pencil? Someone is asking, sir, how much marks we need in S1? Beta, my perspective is, of course, the threshold changes from year to year, session to session, variant to variant. So don't worry about how much marks are needed because you don't know the difficulty level. You don't know the performance of the student. Focus on how much you know, how much you have to give because you're not the examiner, you are the student. So just be calm, relax, just do your level best, and that is what is required from you. So now let's look at this thing. A fair 5-sided spinner has sides labeled 1, 2, 3, 4, 5. The spinner is spun repeatedly until, so that is the key word for geometric probability distribution. A 2 is obtained on the side on which spinner lands. Sometimes it says spinner lands. Sometimes it says topmost face. We don't care. The random variable x denotes the number of spins required. So now it says find the probability x is equals to 4. That means our focus is 2. All the numbers have equal probability. The probability is 0.2. X follows the geometric distribution. X is equals to 4 means the success is on the 4th. There were 3 failures. So failure, 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 success. That is failure cube success. That is the answer, exact. Again, this came again, nothing special. X is less than or equal to n. When it says less than 6, you have to make it less than or equal to. Be very, very careful in this one. In order to apply this thing, make sure that it fulfills this criteria. And now let's look at this one. This one was a nice question. Again, this is one of my favorite. So let me grab that thing. And there were some which were favorite, but maybe I forgot to mention it. So let me write over here. So first of all, I would like to focus on this, that DRV, sample space, and something to do with mutually exclusive, something to do with independent. Just focus a bit more on this one. So now it says two fair five-sided spinners, each with this thing, are spun at the same time. If the numbers obtained are equal, the score is 0. Otherwise, the score is higher minus the lower, the positive difference. That is how they used to write in O-level math. Now it says find the probability the score is greater than 0 given the score is not equal to 2. So have you realized that it's a conditional probability question? Yes, you have. First of all, fill up the table. So there are 5 zeros. And then the positive difference, you see all these numbers. So there is no rocket science in this. Now it says given the score is not equal to 2. So 1, 2, 3, 4, 5, 6. Probability of 2 is 6 out of 25. Probability of not 2 is 19 out of 25. So let me write over here, white color. Probability of 2 is 6 out of 25. Probability of 2 complement, that is 19 out of 25. Now it says the score is greater than 0. Now out of these, because the condition has happened, out of these, the score is greater than 0. So ignore these. How many of these numbers are greater than 0? So first of all, there are 19 options over here. And the score does not equal to 2. And out of those 19 options, 5 were already gone. And there were 6 2s. Got the idea? So what is left? 25 minus 5 is 20. 20 minus 6 is 14. So the non-zeros were 14. The answer is 14 over 19. So how do you like this particular question? Very conceptual. I just did in a very, very simple way. I can do it the other way also using a formula. Let me also tell you the formula. So first of all, listen to me once again. Listen very clearly. First thing, you follow this rule, you fill up the table. Then these 5 zeros are there. There are 6 2s over there. Score does not equal to 2. So just ignore the 6 2s. How much are left? 19. 19 out of this thing. That the score does not equal to 2. I've written it over here. Now, out of these 19, how many are zeros? 1, 2, 3, 4, 5. 5 are zeros, 14 are not zeros. So they are looking for score is greater than 0. At the same time, score does not equal to 2, 14 over 19. Now, this is what the mark scheme method is. Probability A slash B. Of course, we should be aware of this formula. That is probability of A intersection B divided by probability of B. What does this mean? A slash B means probability of A occurring given B has already occurred. So this is given and this is B. B has already occurred. B is the condition. So the condition is what? The condition is greater than 0 and not equal to 2. So that is over here. That is 19 out of 25. And this thing over here, 14 out of 25 is the common one. So 14 out of 25 divided by 19 out of 25, that is 14 over 19. I think this method is beautiful. Just focus on this. Now it says 2 spinners are spun at the same time repeatedly for 9 randomly chosen spins. So 9 is the number of trials. Find the probability the score is greater than 2 on at least 3 occasions. So greater than 2, that is your success. So greater than 2 is 1, 2, 3, 4, 5, 6. That's it. So the greater than 2 is 6 out of 25. 9 is the number of trial. This is the probability of success. A greater than 2 on at least 3 occasions. Greater than or equal to 3. That's 3, 4, 5, 6, 7, 8, 9. Which is easier. 1 minus probability of 0, 1 and 2. Again, write down all these 3 answers, put a plus sign and then simplify. First 4 significant figure, then 3SF. Question 5 was done yesterday. Question 6 was done yesterday. And let me go to the next variant. That is 1, 2, 3. That is this one, 2023. So now let me go over here. So this tough problem was done. This was done, this was done, this was done. Now there are 3 questions over here, and this one is the toughest. So once I'm done with these 3 questions, then I'll show you 1 or 2 questions from the yesteryears, so that you should focus on that, and that include permutation combination question. So stay tuned. And now let's move on. Over here, it says, not over here on the paper, this one over here, 2 fair coins are thrown at the same time repeatedly until, again the word until is there, number of trials is not mentioned. That means this is geometric. And we have seen question in which the number of trial was mentioned, but it was not used because success was happening before that. So until a pair of heads is obtained. So this is basic probability. When you toss 2 coins, 2 fair coins, you get head, 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 tail, tail, head, tail, tail. So a pair of heads, it's 1 out of 4. That is the success. X follows a geometric probability distribution. This is probability of success. Expectation of X is the reciprocal of probability. Therefore, this comes out to be 4. Find the probability. Exactly 5 throws are required to obtain a pair of heads. 5 throws means there are 4 failures and there is 1 success. 4 failures, 1 success. Find the probability fewer than 7. The formula is for lesser than or equal. Fewer than 7 means lesser than or equal to 6. That was very basic question. And then question number 3, this also looks basic to me, just like the previous variant. The random variable X has the values, takes the values 1, 2, 3, and 4. It is given that probability X is equals to X is this thing. It's following this formula. Given that probability X is equals to 4 is 3 times probability X is equals to 2, find the value of A and K. Yes, this is basic, no doubt about that, but this is a simultaneous equation type of basic DRB. So one equation would be the info given, the relationship given, and the other one would be sum of probability should equal to 1. Double check. So first of all, I took this thing. There is right over here, probability X is equals to X is this formula. Probability X is equals to 1, X is 2, X is 3, X is 4. We get these 4 probabilities. The total is 50K. So you can say this is step number 2. And step number 1 was basically following this working. Probability X is equals to 4. So we already have the probability X is equals to 4, which is 24K. So let me focus over here. So that is over here, 24K. And this is 3 times probability X is equals to 2. This is 3 times the probability X is equals to 2. So I think this one should have been my step number 1. And this one should be step number 2. So therefore, I don't have to do the plugging in all over again. I could have used that thing very fast. So now over here, we have it in terms of A and K. The good thing is K cancels out and we first find the value of A. Then 50K is equals to 1. K comes out to be 1 over 50. So I mean, maybe they are too obsessed with pure maths and basic arithmetic that they are making us use this thing again in S1. So this thing is done. Draw up the probability distribution table. Very simple. Given that expectation of X is this, find variance of X. Again, focus on this. There is X squared. This is 1, 4, 9, and 16. It's being multiplied with the numerators of this thing. Why? Because the denominators are intact. So we divide once by 50. And we get this thing and then the variance formula. So these 2 questions were pretty basic. And now this is the favorite question of mine. And this is like if you are getting a difficult question, which 1 or 2 parts you might. So again, this is my favorite. In terms of a difficult question of sample space, and then it's about independent, and I think it's also about conditional probability. Yeah. It's about independent. It's about conditional probability. So this is one of my favorite. Let me write the year over here. So that is May, June 2023, variant 53, question 5. That's right over here. Now, first read this question. It says, Jasmine throws two ordinary fair six-sided die. So everything is fair. At the same time, and notes the number on the uppermost faces, the events A and B are defined as follows. So there are two events. There is a blue event. The sum of the two number is less than 6. Less than 6 does not include 6. Part B, the difference between the two numbers is at most 2. Again, when it says difference, that means a positive difference. Otherwise, they would have mentioned it. It's at most 2. That means it could be 2, it could be 1, it could be 0. First, focus on this very carefully. We are talking about the sum. You have made numerous sample space diagrams like this from O levels till now. There are 36 possibilities, out of which 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So probability that the sum is less than 6 is how much? That is 10 over 36. That is the blue probability. Next one, the difference is at most 2. So just ignore the pink stars. They are there for a reason. First, look at the positive difference. These are all the positive difference, and it's at most 2. So 0 is there, 1 is there, 2 is there, 1, 0, 1, 2, 2, 1, 0, 1, 2, 2, 1, 0, 1, 2, 2, 1, 0, 1, 2, 1, 0. So we have all these things over here. So probability of A, 10 over 36. Probability of B, 24 over 36. Now over here, probability of A complement is the pink one. That is 26 over 36. So what's not A? That is A complement. That is 26 over 36. Let me write over here clearly. So this is 26 over 36. Okay. Now the first thing, determine whether these two events are independent. So are there anything common between these two? The same coordinates giving you this. What do I mean by coordinates? 1, 1, 1, 2, 1, 3, 1, 1, 1, 2, 1, 3. So now if I focus on this, so let me choose a color which I've not used. Let me choose this thing. Let me also take out another color from here. I think this purplish one is good. So now is this thing, hold for a second, let me make it darker. 1, 2, 3. 1, 2, and 3. These three are common. Common in the sense they're obtained from the same coordinates, the x and the y value in that sense. That means this is 1, 1, 1, 2, 1, 3, 1, 1, 1, 2, 1, 3. So yes, the product, the difference is at most 2. At the same time, the sum is less than 6. So there are 3 things common out. Let me move on. Then I have this, this, and this. That is this, this, and this. 3 things more. Next line, this and this. Are these two common? Yes. So that's it. So basically, probability A intersection B is 8 over 36. Got the idea? Now, this is the equation for independence. That is, if two events are independent, that means probability of intersection, the common thing should be the individual probabilities multiplied together. So let me write over here that multiplication. So this is 8 over 36. This is 10 over 36. This is 2 over 36. It's not equal. Therefore, the events are not statistically independent. Got the idea? Or even if you just write not independent, that is perfectly fine. Now over here, let's look at the second scenario. Now, let me just add a page so that you can read further. So we have what options available? We had probability of A, I think that was 10 over 36. We had probability of B, that is, I think, 24 over 36. Let me just double check. Yes, and probability of A complement is 26 over 36. This is subtraction from 1. Now it says probability B slash A complement. Probability B slash A complement. What does it mean? This is probability of B occurring given A prime has already occurred. Given A prime has already occurred. Now, this is the English translation of these wordings. Now, first of all, what is A? Let me get this thing ready. What is A? The sum of the two numbers is less than 6. So what do you think is A complement? The sum of two numbers is at least 6. It is greater than or equal to 6. That is A complement. Got the idea? This is A complement. And what is B? B over here, that was which color? That is the green color. So B over here, what is that? The difference between the two numbers is at most 2. So now sum of the two numbers is at least 6. Check. How many of these have some actually positive difference of at most 2? So it is a very strong question. So now that's where this thing comes in. Now over here, it says, first of all, B slash A complement. What is A complement? The sum of the two numbers is less than, A is sum of two numbers less than 6. A complement is the other one. That is this thing. The sum of the two numbers is greater than or equal to 6. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So out of 24, how many have a positive difference, which is at most 2? So just compare these two. That's what they made it difficult. Go row by row. In this row, there is nothing. There was nothing green over here, which is over here. Actually, one thing, hold for a second. So there is also this thing, which I forgot. That is the sum of the two numbers is greater than or equal to 6. So these two are also there. Got it? So now compare with these green ones. What are the common ones? So from the first line, there is nothing common. From the second line, this thing is common. So that is why I put a star on that. From this line, out of these last 4, are there anything common? 3 are common. Out of these last 5, are there anything common? All 5 of them. Out of all these 6, these 4 are common. Out of these 6, the last 3 are common. Got it? So let me read it again. It says B slash A complement. A is sum is less than 6. A complement is this one. Sum is greater than or equal to 6. Out of these, that is the condition. Out of these, how many have a positive difference? That is at most 2. So the green one is the positive difference. Just check from these how many are green. So that comes out to be 16. So 26 is the denominator. The pink stars are 16, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the answer is 16 over 26. So now that completes this thing. Now let me move to this particular question over here that I want to focus on. That is May, June. Let me write over here, May, June 2021, variant 52, question number 6. The reason for focusing on this is that the combination question. So a lot of people, they have this issue with combination. Let me just look at this thing. Do you have, other than 2022 and 2021 P3 yearlies uploaded? A lot of them. Check it out. So right now, let me focus on my S1 people. So now over here, What are we focusing on? Hold for a second. So we are focusing on this particular question. There is a video. Do check that out. I mean, just type in this thing and my name. And I think it has this title tomorrow. So now over here, it says find the total number of different arrangements of the 8 letters of the word tomorrow. So that is how I break it. TOMORRWO and all these things. So these are the different ones that we have. So let me just go back. Okay. So that is for tomorrow. The first thing, that is without any restriction, 8 factorial divided by 3 factorial for the O's, 2 factorial for the R's. That is basic thing, that is permutation. Find the total number of different arrangements of the 8 letters that have an R at the beginning, an R at the end, and which the 3 O's are not all together. So now a lot of people ask this question, not all together. What does it mean? It means 2 O's could be together, 1 could be separate. That's what it means. So English translation to your mother language, mother tongue, it's very necessary. I would also focus on this question, the green gauge one. I think it's right over here, the green gauge thing. No, not in this one. I think it's right over here. There is aggregate, and let me just get everything in one place. So let me just double check. I hope it's not, yeah, there it is. So the green gauge question, I would also focus on this one. And then I would focus on the probability set notation also. So let me focus on this first. So now over here, there is an R at the beginning, R at the end. The easiest way is find the probability the 3 O's are together. So 1, 2, 3, 4, that is 4 factorial. Nothing is happening inside the box because there are 3 O's divided by 3 factorial. And then without any restriction, 1, 2, 3, 4, 5, 6, 6 factorial divided by 3 factorial for the O's. So the O's are pink in color. So let me give it due respect. So therefore, the 3 O's are over here. That is for the pink. And then the difference is the 3 O's are not all together. So now this is the second part. Now comes this part. That is 4 letters are selected at random from the 8 letters of the word tomorrow. This was the first time that such a question came in which they were asking for the probability. So remember the words. I can use probability. I can use percentage. I can use maybe a chance, something like that, that the selection contains at least 1 O and at least 1 R. So now I'm just looking for one thing. If the question was not about probability and it says find the number of different selections or find the number of ways of selecting. So let me just highlight this. Hold for a second. So let me just erase this thing with a dark marker. So this is my way of what you call modifying this. Find the number, no, not black color. Find the number of ways that the selection contains at least 1 O and at least 1 R. So this is SY modified because that is how usually it's being asked. How many O's are there? There are 3 O's, 2 R and TMW. There are 3 O's, there are 2 R's, and then there is T, M, and W. Let me push this thing to this side. And let me push it like this. Okay. Now it says at least 1 O, at least 1 R. So at least 1 O, I can have 1 O. I can have 1 R. And since I need 4 letters, I'll select 2 from here. I can have 1 O. I can have 2 R's. I will select 1 from here. I can have 2 O's. I can have 1 R. I can select 1 from here. Are there any other options? I don't think so, because it's at least one. Yes. What about yes, yes, yes? There is another one. What about 3? What about 1? What about 0? Yes, that is also a possibility. Now, when we are dealing with identical objects, whether they are letters, whether they are digits, or something else, when we are finding the number of ways of selection, discard remaining identical letters. And one other thing, that is, do not use NCR. Got the idea? So now, if this is the scenario, if I choose 1O, discard the rest. Basically, if I use 1O, discard the rest, they are all like photocopied paper. If I choose 1R, discard the rest. So I won't write anything. I'll simply write 3C2. Over here, choose 1, choose 2, just choose 1 out of these 3, that is 3C1. Choose 2, choose 1, just 1 out of here, that is 3C1. Choose 3, choose 1, just write 3C0. So this is 3, this is 3, this is 3, this is 1. That would be total number of ways. That will be 10. But how is this question different over here? So now over here, 4 letters are selected at random. Find the probability selection contains all these things. So this combination is the same as on that page. And over here, there is also one other 2-2 thing, which I forgot to write because I was focusing on that particular thing. So let me go back. And yes, there is this 2-2 thing also, black marker. There is 2, there is 2, there is 0. That is also this one. So therefore, 0, this is again 3C0. So this is 3C0, which is also 1. So just double check. This is 112. Let us focus on this thing first. 112 and then 220. So first focus 112 and 220. And then what else is there? There is this, all these different options are there. Okay, come back to this. Over here, when I want to selection contains at least 1O, at least 1R, so it is 112, and the positions are different. And this is like 121, this is like 211, this is 220, this is 310. Now, since it's about probability, we would treat it normally. So probability, treat it normally, not like identical stuff, identical objects. That is what I'm focusing on. So basically, this is 3C2, 3C1, 2C1. This is 3C1, 3C1, 2C2, and so on. All the possibilities is 50. Without any restriction, 8C4 is 70. 50 over 70 is the answer. Selection, number of ways, $300 bill. A waiter arrives. They're asking for one of the bill. There are 2 remaining in the pocket. So when we talk about probability, $100 bills are identical, 1 out of 3. When we are selection, just select any one of them. It doesn't make a difference. But when we are taking the probability, you are choosing 1 out of 3. So do watch that video for this particular thing. Now, this very famous question, green gauge, one of my favorite. Find the number of different arrangements in which 9 letters of the word green gauge can be arranged if exactly 2 of the G's are next to each other. So green gauge, there are 3 G's, there are 3 E's, there is R, N, and A. Now, exactly 2 of the 3 G's are next to each other. So this is method number 1. Without any restriction, 3 G's separated. They all are separated. 3 G's together. And therefore, without any restriction, minus the 3 G's separated, minus the 3 G's together, that means the 2 G's could be together. Got the idea? Listen to me once again. Without any restriction, 3 G's separated, space concept. 3 G's together, box concept. So what is now left? what is now left is that exactly two of the G's are next to each other. So this minus this, that is the answer. Another method. Make a box of two G's, work in spaces. The G could not be over here, because we only want two G's to be together. The G could be 1, 2, 3, 4, 5, 6 places, 6p1 for a single G. 1, 2, 3, 4, 5, 6, 7, 7 factorial, divide by 3 factorial for the 3 E's. For the box inside, nothing is happening, 2 factorial over 2 factorial. And now the last thing that I want to focus on is this thing. Again, this is my favorite. When we are talking about this general probability formula, this is derived from set notation, probability of A or B. What does A or B means? Either A or B or both. And what does A and B means? Both A and B. That means if you want the union of anything, add up the probability of individual events and subtract if there is anything in common. And if there is nothing in common, that means it is mutually exclusive, because that's what the definition of mutually exclusive is. Now, let me revise this thing and let me show you some small questions on this. Mutually exclusive events, probability of A intersection B is 0. That is the only condition. There is no other condition. Because of this, the formula reduces to this. That is simple addition. That is something else. That is the output. That is the byproduct. But the condition is what? A intersection B is 0. What is the definition? Events which cannot occur simultaneously. Toss a fair coin, you get a head or a tail. Roll a die, a fair die, you get a 5 or a 3. Roll a die, you get an even or an odd. CI exam, you will get your A or not an A, God forbid. You will inshallah get your A's. Weather, rain versus no rain. Match, win, draw or loss. So these are all examples of mutually exclusive events. What are independent events? Outcome of one event does not affect the other. Affect with an A, influence. Roll a die, toss a coin. If I roll a die, let's talk about the number 5. Probability of getting a 5 is 1 over 6. Probability of getting a tail on a fair coin, it's 1 over 2. Draw a sample space diagram. How many dots do you see? 12. What is the probability of getting a 5 and getting a tail? So that is 1 out of 12. Is this probability a product of the individual probabilities? Is probability of 5 intersection T equal to probability of 5 into probability of T? Yes, it is. Therefore, the two events are statistically independent. Now, some basic examples. Probability of A is this, probability of B is this, probability of A intersection B is 0.2. Just a simple calculation, find probability A union B. That is the general probability formula. Add the probabilities. If there is any intersection, subtract. Now, the next one. Probability of A is this, probability of B is this, probability of A intersection B is 0. Is this mutually exclusive? Yes. Therefore, evaluate probability A union B. That's a simple addition. So simple addition of two events or more than two events. Probability of C is 0.5. Probability of D is unknown. Probability of C union D is 0.8. Given that C and D are mutually exclusive, find probability of D. So when they are mutually exclusive, the union is simple addition. This is 0.8. This is 0.5. So probability of D comes out to be 0.3. Something more. Probability of A is 0.4. Now this is ETQ, exam type question. Probability of A is this, probability of B is this. Given that A and B are independent, evaluate A intersection B. Since it is independent, intersection is the individual probabilities multiplied together. And then evaluate A union B. That is the whole formula, except that this last part is obtained by multiplication. As simple as this. And then C and D are independent. Find the value of X. Probability of C, 0.6. Probability of B, X. C union D is 0.9. Find X. So now work it out this way. First, find the intersection, then use the general formula. First, find the intersection. Because it is independent, it is a product of 0.6 and X. And then the general formula, or means union. Probability of C, probability of D minus the intersection, it's 0.9 over here, X comes out to be 3/4. Last question, probability of A is 0.5, probability of B is 0.3, probability of intersection is 0.2. Are the events mutually exclusive? For mutually exclusive, intersection should be 0. It's not 0, it is 0.2, therefore it's not mutually exclusive. Are the events independent? Is the intersection equal to the individual probabilities multiplied together? No, it's not. The two events are not independent. Don't worry about what it is. This is just a theoretical question. And they have asked in the very initial years, I think it was November 01 or November 02, they have asked this question and they can strike once again. So now, people, that was all from my side. And just focused on your timing. Watch, if you have time right now, watch the video October, November 2024, variant 53, very important. Watch the video February, March 2025, variant 52, very important. There are some good questions over there. Check those out. Check out the timing issue. Let me give you a brief idea. The first 5 questions should be done within 45 minutes max. If you find anything difficult, leave and move on, rather than quarreling with it. So do not argue, quarrel with the difficult question. What you should do, move on. Come back to it at the end. And if your 5 questions are done in 45 minutes, then 2 questions, the last 2, sometimes it's 6, sometimes it's 7, the last 2 can easily be done in 20 minutes. That will leave behind 10 minutes. Take care of accuracy. Take care of fractions. Take care of show all working. And you are all set for the exam. My prayers are with you. Inshallah, you will all do wonderfully well tomorrow with your A star geared up for your A2 exam. So an A in P1 S1 will eventually land with you an A star in your A2 exam. Take care, everyone. Nice knowing you all. Stay tuned for more content on mathematics with Shahab Yaqub.